Hello there. Welcome to our today's science lesson. The topic for the day being particles in elements and compounds. In our previous lesson, we looked at an overview or general knowledge one requires to have for us to be able to understand some of the aspects which I'll be looking at in this topic of elements and compounds, where we touched on so many areas: elements, compounds, mixtures, how to write the symbols, how they came about, and anything related to that. In our today's lesson, we want to be a little bit more specific, to look at elements, some of the elements, when they were discovered, and their functions, when they are discovered and what are they commonly used for. And in looking at when they were discovered, we also have to look at some of the scientists that did as a very big favor of doing the lots of work to discover those elements that are very helpful in our lives today. In general, we have about 118 elements that are well arranged in the periodic table, and out of the 118 elements, 92 of them occur naturally. At any single moment, if you want to get in touch with them, you can be in touch with them. However, the others that are not in the 92 do not occur for a very long period. Then, if they don't occur for a long period, when are they found? They are usually found during radioactive decay, radioactive reactions, where known elements out of the 92, known elements can undergo a reaction, what we call a radioactive reaction or a radioactive decay, and in doing so, new particles may come up. And one of, or some of those particles that come up from that decay are these other elements that are not in the 92 elements. In so doing, they undergo further reactions leading to them not existing anymore. This shows that they have what we call a shorter half-life, something that we may learn later in our other lessons. What will be that half-life? Now, here on Earth, in the universe, we have so many things. Starting with where you are seated, look around. You can see so many things. Look at yourself. Did you apply anything on your body today? I'm sure yes. You took a shower. Did you use anything when taking a shower? The answer is yes. I'm sure you are warm. You are clothed. Look at that piece of cloth. Does it look like your shoe? It doesn't. And so many other things around you. Look at the pen you are using to write. Look at the seat you are seated on. All those substances or all those materials are made of substances. And these substances are different. That's why you didn't take a material, or whoever made that shoe didn't take a material from a piece of cloth to make that shoe. They had to look for a material that will suit making a shoe, that will suit making a pen, that will suit making a pencil, and so on. How do these materials come into existence? They all come from the elements we have just talked about. The 92 elements plus those that occur for a very short period, but majorly from the 92 elements. But one can ask, but how can an element, just an element, become a shoe? Just an element become a pencil? The answer to this is when you have so many elements put together, they will come up with one particular substance of a particular character, of a particular behavior, which will be suiting what you wanted. These elements can be of the same atom, same material, because an element and an atom is almost one and the same. So these elements, these atoms, when put together and they are of the same, they will make one particular thing that you will say, this thing is of a particular character. However, you can also have so many different elements put together. They will also come up with a particular substance which will automatically have a different property or a characteristic from the other one. Give an example of a wire, just a piece of wire. I'm sure where you are seated, probably there is a gadget nearby, a TV, a radio, computer. It has a wire. Even the lighting in that building, there are wires that were used in connecting. Which type of material was used? That is copper metal. So what does it mean? For us to form that copper electrical wire that was used in connecting, so many copper atoms were put together, meaning atoms of the same element. The element being copper were put together and made into one particular thing called a copper wire. So here we are talking about so many atoms, but of the same type, put together to form one big thing that is now being applied as a copper wire to connect so many things you may be maybe even doing at your own free time. But we also have some other elements that can be put together to form one other substance that is totally unique of what you have already talked about. I'm sure where you are seated, probably, if you are in a classroom, you had a break. During that break, probably you had tea. You had a soft drink. Out of that soft drink, I'm sure it was tasting very nice. It was sweet. Why? Sugar is in it. Then let's look at sugar. What is sugar? In terms of elements, sugar is made up of carbon as an element. It is made up of oxygen as an element, and is also made up of hydrogen as an element. But these elements are in a particular ratio and in a particular arrangement. So there's one thing that is also coming in. Don't just look at the elements, also look at how they are connected to each other. And when they are connected, the forces holding them together will vary. Just like what we saw in our previous topics, where we were talking about forces that hold particles in gases, liquids, and solids. So these forces will vary. And because of the different way of connecting these elements together, with the different forces at different positions, we come up with a particular structure that will have a particular characteristic of that particular substance. And in this case, we are talking about sugar or glucose. So glucose, you will find that glucose has 6 atoms of carbon. It also has 6 of oxygen and 12 of hydrogen. These ones are connected in a particular format, so that in that particular shape, format, structure is when we can have that particular characteristic called glucose as a substance or sugar as a substance. Now, we have just looked at elements, and those elements put together have now formed what we call a compound, just like sugar. So that's a compound. Now, we need to realize that most of this information we are talking about came from somewhere. And this information is about elements. There are scientists who worked tirelessly to come up with this. So going by the order of how they were discovered, we need to start with, first of all, some of the elements that were used in the ancient world. So we can't really tell who really discovered these elements. So we shall start with those ones. We can assume those are the ones that came in first. And some of these are: 1, copper. Copper as an element, it has a chemical symbol of Cu. Capital letter C, small letter U. This is one of the elements that was discovered in the ancient world. We also have another one by the name lead. We also don't know really who came up with the idea that this element we are talking about is lead, because it was used very early in the days, that's in the ancient world. We also have others like Mercury. This was a very unique element because it is a metal, but a metal that exists in a liquid state at room temperature. And because of its characteristics of being a liquid and it is a metal, it is used in so many areas, as we shall be looking at the uses of some of these metals in the course of the lesson. So mercury has a chemical symbol of capital letter H and small letter G. The other element that was discovered by, we can't tell who, but it was used heavily in the ancient world, is iron. Iron, which was used in the smelting of metals to form spears, knives by the early man. Iron is vastly found, and I'm sure you also know that iron is one of the metals that is heavily used here on our universe. It has a symbol of capital letter F, small letter E. The other element that was used in the ancient world is sulfur, which happens to be the only non-metal in our case here, sulfur. Sulfur is one of the elements that was used in early life, and it has a symbol of an S. Now, from what we are seeing, the name and the chemical symbols, the elements you will find, the name and the symbol have an agreement, whereby the symbol carries probably the first one letter or two letters of the name, but some will be carrying different names. This is because of the original names that were used before coming in with the present name that we are having for the same element. Picking an example of iron and copper, because I mentioned in the previous lesson, looking at copper, we expected it to be CO, being the first letter. But because other elements could have been discovered and they have the same symbol, and an example here is cobalt. Cobalt has CO. So we cannot use CO just because copper is starting with the CO, because we have another element by the name cobalt which has a chemical symbol of CO. So looking at copper, starting with the CO does not guarantee that we use CO as the symbol, because this one is used by another element by the name cobalt. So The formula had to come from the original name of copper, which was cuprate, giving us the symbol as Cu. The same applies to iron, which instead of picking on IR, we are using capital F, small e. Reason being, the original name for this iron was ferrous or ferric. Ferrous substances that have iron in them. Because of that, the symbol comes out to be Fe. Now, these are the elements that were commonly found in the ancient world, which are commonly also being applied in our present life in various uses, as we shall see. The other elements that we are going to look at are those that came into our understanding through the work of some of the scientists in the early years. I will go in order of years, and in 1766, a scientist by the name Henry Cavendish, in 1766, that's early, so much early. This guy must have worked tirelessly. Henry Cavendish, he came up with an element by the name hydrogen. And hydrogen is one of the most important elements we have here on Earth, because hydrogen as an atom, when they combine two of them, they come up with a molecule of it, which is a hydrogen molecule. And it is this hydrogen molecule that now, so many together, we call hydrogen gas. So when you have hydrogen gas, you can come up with so many other things. Very helpful indeed. You can talk of rocket fuel, which is very important in the astronomical world. You want maybe to send a satellite into space. You need something to carry it that is energetic enough to escape gravity and go. How does it become energetic? It must use powerful fuel. This is the fuel that is normally used. We have hydrogen gas combined with the oxygen. When you burn hydrogen gas in the presence of oxygen, a lot of energy is given out. And that a lot of energy is what makes the rockets be able to escape gravity as they take satellites that make us communicate with all our people, all the areas here on Earth, as vast as it is. The other element is oxygen, that was discovered second, and that is in 1772 by a Swedish scientist, Carl Skill. Carl Skill in 1772 discovered oxygen. So this one was in 1766, and now we are talking about 1772. Henry Cavendish did the work on hydrogen, and here now we have Carl Skill, who discovered oxygen. Looking at the proximity of years, probably this Carl Skill as a scientist really saw that this hydrogen that has been discovered, it is doing some other kind of reactions that are sequentially being seen. And Carl Skill really wanted to know what is this other gas that is doing some sequential way of reactions with this hydrogen that has just been discovered by Henry Cavendish. And at that time, he came out to discover that that substance or that gas or that element that was being talked about was oxygen. Now, oxygen as an atom is what was discovered in 1772, which when two atoms come together, they form an oxygen molecule. And when you have so many oxygen molecules together, then you come out with the oxygen gas, which also has so many other uses, as we shall look at it in the course of the lesson. In the same 1772, we had two scientists, Joseph and Rutherford, discovered another element by the name nitrogen. Nitrogen. So in the same 1772, Joseph and Rutherford, those are two scientists, they came up with another element by the name nitrogen. And looking at nitrogen, this is a very helpful element because when it combines with another nitrogen, it comes out to form nitrogen gas. Nitrogen gas is very helpful in the universe, particularly in the atmosphere and so many other areas. Without nitrogen, there will be no regulation of combustion. Now you can imagine where you are seated there. Fire breaks out in the kitchen. If you are in a school setting, probably there's a kitchen around, then fire breaks out in that kitchen. Without this nitrogen, which holds the biggest percentage of the atmosphere of about 78%, the other gases, the other substances in the atmosphere carries the other part. But 78% is nitrogen. Why? Nitrogen is a regulator. When you look at how nitrogen molecule is formed, you find that it has 3 bonds between the 3 types of forces that holds the 2 atoms together. Being 3, it makes it very strong. So breaking this nitrogen molecule is not easy. Now, if it is in large portion as it is, and a fire is there, there is no way the fire can spread because oxygen is in the other areas. No. When it meets nitrogen, nitrogen will be unable to break. So it will stop it and limit it to that point that is burning. If it's a piece of paper, it will be limited to that particular point. So as you can see, Joseph and Rutherford did as good by discovering that we have an element by the name nitrogen, which leads to formation of nitrogen gas that is very helpful. In 1774, Carl Skill, the same scientist who discovered oxygen, also discovered another element, and the element is chlorine. The new element is chlorine. So in the same Carl Skill, who did the work in 1772, in 1774, he discovered an element called chlorine. Chlorine is a poisonous gas when it is in a gaseous form, and is written with a symbol of capital letter C, small letter L. L must be written as just one without any simple bend. Any small bend, as I've shown here, this is wrong because this one makes it to be interpreted as a capital letter L, which by rules of writing the symbols is wrong. So our L is written as this. So this is the formula of chlorine as an element, which when you bond 2 of them together, you will come up with the chlorine gas, which is a poisonous gas, but it being poisonous does not limit it to so many good uses, as we shall see later on. Then came another scientist who did really some good work. He discovered 4 elements. A scientist, a British scientist, who discovered 4 elements, and that is Humphrey Davy, Sir Humphrey Davy. Sir Humphrey Davy discovered 4 elements. And this was, the first 2 elements were discovered in 1808. And these were sodium, these were magnesium and calcium. That is 1808. And in the same way he did this, in 1809 he discovered sodium and potassium. Now, looking at the sequence at which he discovered these elements, he probably based on properties of these elements. Because if you look at the periodic table, these 2 elements, magnesium and calcium, have something in common. They are all found in group 2 of the periodic table, meaning that they have something in common, and that's why they were placed in that group. Because if you have so many items and you place them in groups, what do you normally base on to place them in groups? One can be color, that is a property. So you can say those that are red, this place. Those that are green, the other place. You are looking at that property in the name of color. You can also look at probably if there are students, those that are tall, those that are short, those that are probably looking at the type of clothing they are having, bright clothing, dull clothing. So you look at properties. So these 2 elements have something in common, and that's why they are found in group 2 of the periodic table. And that's why probably they were discovered in the same year. Each one of them has its own story to tell in terms of uses. 1 year later, that is in 1809, sodium and potassium were discovered. Just like magnesium and calcium, also these 2 elements are found in the same group, which is group 1 of the periodic table. Group 1. Looking at the electronic configuration as we saw in the previous lesson, here in the outermost energy level, will be carrying 2 electrons for group 2, and here they will be carrying only 1 electron in the outermost energy level, making them to have the same characteristics. So this is the work that was done by our dear Humphrey, scientist, a British scientist, Sir Humphrey, who gave us the 4 elements. In 1827, a German scientist by the name Frederick discovered aluminium. That is in 1827. This a German scientist discovered aluminium. Look at how aluminium is also written. Capital letter A, small letter L. That's the correct way to write aluminium. It was discovered in 1827 by a German scientist, and aluminium is a wonderful metal because of its uses. It's a very unique metal, very strong and light. And you'll discover that in most cases we always want strong things, but easy to manipulate, easy to carry around, easy to move with. So you find that aluminium comes in very handy in this case. Being strong and light, it is so nice to have it. It was discovered in 1827 by a German scientist, Sir Humphrey Davy. Frederick Wohler, a German scientist. Then lastly, let's look at helium. Helium was discovered in 1868 by Pierre Janson, a French scientist. Helium. This French scientist discovered probably that there's a gas that is being used probably in so many ways. but cannot be able to react like other gases. And the gas was helium. So in 1868, French scientist discovered helium that has so many other uses as we are soon going to look at. So having looked at all these elements, those that were found to be used in the ancient world and those that have been discovered by the scientists I've just mentioned, let's look at each one of them and some of the uses that are associated with that element. Starting with the copper. I will use for all the chemical symbols. Now that I've been giving out the chemical symbols, we now have a concrete command that looking at this, we shall all agree that this is copper as an element. So copper as an element is used to make copper as a metal. When you have the so many atoms of copper together, you come up with the copper metal. Now, what are some of the uses copper can be used for? Copper, in some of the areas, even here on Earth at present, is still being used in the making of coins, money, coins, which is very important. Why? Because copper does not undergo corrosion easily. Money can be handled in very different ways, some of them being very dangerous. It comes in contact with the dangerous chemicals. So we need a material that can resist some of the harsh conditions. And copper was picked on to be used in the making of coins. The other thing is, as I mentioned earlier, is used in making wires, electrical wires. There are so many appliances you might have interacted with. Each of that appliance cannot do without a wire. If you are in an electrified room, that electricity, how was it wired? Look at where the switch is and look at where the bulb is. Whatever is connecting the two together is a wire, and that wire is commonly made from copper. The other reason why copper was chosen because of this, some of these functions, is because of the expense part of it. Copper is relatively cheaper. It doesn't mean that copper is the only one that can be used to make a wire. No, others can be used, but some of those other metals are relatively expensive when you compare it to copper. The other metal is lead. Lead was also used in the ancient world, and it is commonly used as a soldering wire. Soldering wire. If you open a gadget like a radio, a TV, computer, you will find a motherboard. On that motherboard, you will see silvery parts that are being used to connect some of the components on that motherboard. The silvery part that is normally used is made of lead. Reason why lead is used is because it can easily melt at high temperature that can be achieved by some of the appliances we have that can be used in soldering. You can even heat just a piece of metal like iron nail. Once it starts glowing red, you attach it on lead, it will be able to melt. So because of that, it is commonly used for soldering. Lead is also used in car batteries. If you look at a car battery, it has terminals. These terminals are made of lead. And going by the chemical reactions that take place in the car battery, one terminal will be positive and another one is negative. This can only work when you are using lead, because lead has two oxidation numbers. Lead forms oxidation number 2 and oxidation number 4. Because of these two oxidation numbers, it is easier to make one positive and another one negative based on the reactions that will be taking place between the lead terminals and the sulfuric acid that is usually poured into the battery as an electrolyte. So those are the uses of lead. The other element we can look at is mercury, which was used in the ancient world. Mercury is a metal that exists in the liquid state, and because of that, it easily expands when heated and contracts when cooled. Mercury is a liquid but a metal which behaves in a special way such that when you increase temperature, mercury expands. When you lower the temperature, it contracts. Because of that, mercury was commonly used in thermometers, and up to present it is still being used in making thermometers, such that when it is in a bulb form, inside a thermometer, a piece of glass that has been calibrated, when you touch the bulb and make it warm, you make the mercury to expand. By expanding, it will have to rise up through that tube inside the glass. Through the calibration, you can easily tell how much warm your hand was, or if your hand was cold, and the mercury then will be seen dropping. By how much it will drop will mean the extent of your coldness or hotness of your hand. Because of this also, mercury was used as an electric switch. Take a situation whereby fire has just broken out in a room. Because of the fire, the temperatures will rise. If you have an electric switch made of mercury, it will make the mercury to expand. By expanding, it will go and reach a certain level where once it reaches, it completes a circuit. Because remember, mercury is a metal, therefore it conducts an electric current. So by touching that point, due to the expansion, it completes the circuit, and in so doing, it makes a bell to ring, which will be alarming the people around that a danger has just arisen because of fire, high temperature. So mercury was used in making electric switches because of that. The other substance, the other element is iron. This one is like the mother of it all, because you realize that in the early life, most of the tools that were used by the early man, they were made of iron. Look at the ship. All types of ships that are used, or marine vessels that are used, their bodies are made of iron. But this iron easily undergoes corrosion. So how is this iron treated? It is mixed with the other metals to form an alloy, which will come out to call steel. Steel is an alloy of iron, which is very strong and resists corrosion, so that it can be used in these various ways, like making bodies of marine vessels. Iron is also used as galvanized iron. You can just have iron as iron, but you cover it with some other materials. Look at some of the buildings that use iron sheets on their rooftops. Iron sheet will not appear gray as iron. It will appear probably shiny, silvery, or other colors. That is just galvanization. The iron has just been covered by other substances so that to reduce on the corrosion of the iron. But iron has been used because it is strong enough to resist some of the mechanical pressures or stresses such a material can be going through. The other substance is sulfur. Sulfur was also used in the ancient world, and it was used in the ancient world in so many ways, one of it being in making pesticides. pests are all over, and they will always interfere with our daily good life in terms of reducing on the production of some of the crops we grow. So to increase our productivity, then the crops must be sprayed by pesticides to kill those pests. It is also used in making of fertilizers, sulfur-based fertilizers like sulfates, which are very important in growing some plant materials like flowers. There are some particular flowers that requires much of sulfates as an ingredient in their well-being and even the general healthy growth of a plant. Lastly, we can look at carbon as a second nanometal. These others have been metals. Sulfur and carbon are nanometals. Carbon is a unique nanometal and is commonly used, like probably where you are seated, you have a pencil. Look at that pencil. Look at that lead, the writing point of that pencil. That writing point is made of carbon. Then one can easily ask, then how? Carbon is found in various forms, and one of the forms is called graphite. So graphite is another form of carbon, which because of its connectivity in graphite, carbon in its connectivity to form graphite, it exists in layers. So carbon forms layers. These layers are held together by weak forces. So take an example of a book that has so many pages. So those pages are layers of carbon, and between the pages is a weak force. That's why you can easily turn over a page and still leave the other page lying down, because the forces holding the pages are very weak. So if those forces are weak, when this first part is in touch with a surface, it will attach itself on that surface so strongly that it cannot move away. So what will happen is this second layer will have to slide over this one, break these forces in between, so that it now comes to attach this point A to come at point B, so that it starts from here to the surface again. Because of the high force of attraction between now that second layer and the force of the surface, it sticks there. So we are remaining with this was 1, 2, 3, 4. We are now remaining with 3 and 4. The same happens to this 3. Break the forces. 3 comes here on the surface. Break the forces again. 4 comes here on the surface. What are you doing? You are drawing a line. This is because carbon in the layer form is sliding over each other to go and form that line. So it is used in making pencils. It is also used in making lubricants because of the same property, whereby it is existing in layers that are sliding over each other. In fact, this lubricant is a very good lubricant in particularly heavy machines, whereby due to friction, temperatures can go as high as 300, 400 degrees centigrade. Look at a drilling machine. You are drilling a well. You are drilling through a very thick rock. Because of the gears crashing over each other, the temperatures will go very high, where you cannot apply the common lubricants we have. They will evaporate. So what we normally use is graphite as a lubricant, which is made of carbon. So those are the elements that were found to be used in the ancient world. Let's look at the ones that were discovered by the scientists that we have just talked about. The first element here is, let's look at magnesium, calcium, sodium, and potassium. These are 4 elements that were discovered by one scientist, Sir Humphrey Davy, who is a British. Magnesium as an element is used to make magnesium metal, a metal by the name magnesium. This metal, when in the lab, when you ignite using a strong flame, the magnesium metal, which is made in ribbon form, it's just a thin sheet in ribbon form. When you pick a piece of that magnesium ribbon and you use a strong flame, the metal will start burning, and burns with a bright white light. The flame is bright white, just like what you normally see in fireworks. So, since it burns in that flame which is hot enough and does not burn in a flash, it takes some time, you can have a piece of fireworks and on it attach that magnesium ribbon. This is our magnesium ribbon. When you ignite it, it will continue burning. Since this flame is hot enough, once it comes in contact with these fireworks, then it will explode. And it will have given you enough time to throw the piece of fireworks to any height that you wanted, because this one will take some time as it burns. Having looked at the calculation of time taken for this one to burn completely, to come in touch with this, you will have known that this piece of fireworks will have reached the height you wanted, maybe 10 meters, 100 meters, 200 meters. You remember when you are talking about New Year's celebrations, this happens. Some will go as high as half a kilometer, 500 meters. So you'll have calculated how long this piece will take to burn before it comes in contact with this, so that the heat energy makes this one to explode and gives out that good scenery you always see. The other element that is close to this is calcium. These are group 2 elements. Calcium is commonly found in bricks. It makes bricks to look the color they look, goldenish, reddish, orangish in color. It is because of calcium. Because calcium as a metal, when you burn, it burns with a red color. So it is the one that gives that brick that characteristic color. It is also used in glass industry. The details of it cannot be able to be explained properly in this setting, but it is used in the glass industry. Formation of glass, colored glass. You can meet a transparent glass, which is so common, but we also have blue, red, green, orange, all those colored ones. We normally use calcium in making of those glasses. The other 2 elements that are also close to each other are sodium and potassium, discovered in 1809 by the same scientist, Sir Humphrey. That is sodium and potassium. When I was starting the lesson, I asked you, look around. And one of the questions was, did you probably take a shower in the morning? The answer was yes. Then, have you ever asked yourself, how is that soap prepared? Here comes the answer. These 2 elements are key ingredients in making of soap. When you have potassium and sodium as a compound, remember we are talking about elements and compounds. So this element sodium, this element potassium, when it meets other elements to form a compound by the name sodium hydroxide and potassium hydroxide, these compounds are used in making soap. a process called saponification. So you will make that soap, go to that shower of yours, feel happy when you come out of that shower because you are clean. So one of the uses is they are used in making soap. Looking at sodium particularly, sodium is also used in making of bulbs, lamps. You have moved through some streets and you find a certain lamp or a bulb burns with a characteristic color that is not bright white. It is yellow or golden yellow in color. Whatever is put inside the bulb, if this is our lamp or a bulb, for us to balance the pressure in this lamp, outside and inside. Remember, this is glass. If you don't have anything inside, the pressure outside will break this glass, because inside will be a vacuum and outside there is pressure, 1 atmosphere. That is very high pressure. You can imagine this pressure is balanced by the pressure of your heart. You want to know how much pressure it is? You are running around, your chest is bumping so strongly, just get hold of your heart. Feel how it pumps. Then imagine that pressure, as high as it is being balanced by the pressure from the outside. So look at this situation. If this glass, which is very thin, inside there is nothing, but outside we have 1 atmosphere, what will happen automatically? This one will break. So what we do, inside there is a filament which is glowing, and as it glows, it comes in touch, it interacts with a gas inside. The common gases we normally use are noble gases because they do not react with the filament, so that they form a different compound which will stop the filament from doing its work of glowing. But we always don't just use noble gases. We can also use sodium gas. Remember, sodium is a soft metal. At slightly high temperature, it will just vaporize and form sodium gas. Because of what we also looked at the previous lessons, the series, Pascal's series, Palmer series. There's a scientist who discovered that there is movement of energy. And I remember having said that when an electron moves from one energy level to another, that is also called movement. When an electron in sodium metal does the same, it gives out light that is characteristic of sodium, what we commonly use in flame test. Flame way of identifying metals. So the color that will be given here is yellow. So giving a characteristic yellow color of this lamp. So that's where we also apply our sodium metal. The next one specifically is for potassium. Potassium as an element specifically. Being very reactive, it is used in explosives. Being very reactive, it is used in explosives, which are good because you might be in a case where you want to break a rock. In addition to other types of explosives, you can also use an explosive made from potassium. The other element is aluminium, which I said that is a unique metal. Aluminium is a very strong metal, but light by density. Because of that, aluminium is used in making planes, the bodies of planes. A plane is supposed to be strong to resist all the interaction, the atmospheric interaction it will be having as it flies. But at the same time, it must be light so that it will allow so much to be carried on the plane. So aluminium is the one that is used. And even in some parts of the world, aluminium is also used in making sulfurious or cooking materials, because it is strong enough to resist strong heat coming from whichever sources of heat, and also does not easily get corroded by the atmospheric conditions, because when it meets oxygen, it reacts with it to form aluminium oxide, coating that surface of the material, which is not easily corroded. So this aluminium oxide is what is normally used to protect aluminium metals. The other elements can also look at is helium. Helium is a noble gas and was commonly used in making balloons, filling up of balloons that are used in detecting what is to happen in the atmosphere. Send out a balloon, you must use a gas that is less dense than air, so that it can be allowed to go. Again, this gas should be having other properties that it should not be able to react with other substances, and therefore helium was used. Remember, this one is found in group 8 of the periodic table, and therefore it is a noble gas, unreactive, and that's why it was used in balloons, having been discovered by a French scientist by the name Pierre. To summarize, to finish up our lesson, let's look at these two elements, and that is hydrogen and oxygen. These two are very important in our lives, both directly and indirectly. Hydrogen gives us hydrogen gas, and oxygen gives us oxygen gas. As I mentioned earlier, these two are normally used as a rocket fuel, meaning that during combustion it gives out a lot of energy. Hydrogen also as a gas can be used in various cases. Like, for example, when you have margarine. What is margarine? Margarine is just an oil. Oil is in liquid state. But margarine, when you are applying on your bread, it is in solid state. How does it acquire the solid state? It is through a process called hydrogenation, where hydrogen is being used just to harden the oil, which is very important, and in so many other cases of similar fashion. Oxygen, it is used also in other areas, one of it being oxidizing some of the substances you will wish to be in oxide form. For example, you have just seen aluminum oxide. When in oxide form, it can be very resistive to some of the conditions. So all in all, we have seen that we have so many elements which are in the periodic table, 118 in number, 92 being the ones that are naturally existing. And each of the element was discovered at its own time. It has its own symbol, and each one of them, because of the characteristics, they have their own uses. That marks the end of our lesson today. Thank you.